afternoon, Hartspool. This afternoon we're going to be looking at improper fractions. We're going to be looking at what an improper fraction is, how we can determine what an improper fraction is, and how we can then convert it into a mixed number. So first of all, what is an improper fraction? Let's have a look at some of these. If we look at our 1/2 to begin with, I'm going to take a different colour. We've got 1/2. We can see our fraction. If it's a normal proper fraction, we have our bar model where the whole amount has been split into halves. It's been split into two. And our numerator tells us that we have 1/2 shaded out of 2/2. That's a proper fraction. Let's have a look at another proper fraction. We start off, we have 2 bits shaded out of our shape. You can see this time the biggest difference is our shape has been split into 3 equal parts. So it's 2/3. Again, we go over to 3/4. Our shape has been split into 4 equal parts. And within that, we have 3 that have been shaded. These are what we call proper fractions. Let's have a look at this last fraction at the bottom. There's something slightly different about it. Now, if you notice, this time our numerator is larger than our denominator. That's how we know it's an improper fraction. I'm going back to what we were doing earlier. I can then colour in 6 equal parts. But look, 1, 2, that's 1, 2, 3, 4. I've coloured 4 in, but I haven't got enough space. That means I have one whole shape. I'm going to need to make another bar model. And I'm going to continue to colour that in. 5, 6. Essentially what this means is I have one whole one, which has all been coloured in. One whole. And then in my bottom shape, I have 2 quarters. Okay, so depending on how many whole ones we've got filled, depends on how many we've got there. Let's have a look at another example. So this time I've got 17/5. So I've split my bar models into 5s. So in each bar model, I have 5 equal parts. I start by shading in. I'm going to count up to 17. 1, 2, 3, 4, 5. I have one whole one. 6, 7, 8, 9, 10. I have another whole one. 11, 12, 13, 14, 15. I have another whole one. 16, 17. So in this last shape I have 2/5. I can then do these 3. So 1, add 1, add 1 equals 3. That makes my whole number. And I'm going to bring my fraction over to join it, which equals 2/5. There's another way we could work this out though. We could use an abstract model. Our abstract model looks like this. We take our numerator, so numerator, and we divide it by the denominator. So in this example, we've got our numerator is 17 divided by 5. How many 5s go into 1? None. Link them together. How many 5s go into 17? 3. I know that's 17 minus 15 is 2. I have none left over, so remainder 2, which becomes 3 wholes and 2/5, because all we need to do is bring our divisor over and make it across. Let's have a look one more. 9/6. So first step, I'm going to shade in 9 of them. 1, 2, 3, 4, 5, 6. So I've got one whole one. 7, 8, 9. I stop. So I've now got, in this part, 3, 6. So essentially, if I put these two together, I've got one whole. That's this part, the whole coming in. And I've got 3/6. Let's try it in that other method. So to remember, it was numerator. What was it divided by? Denominator. So what am I going to do? I'm going to make my bus stop. I'm going to put my numerator in the bus stop. 9 divided by 6. Well, how many 6s can I get into 9? Or 9 divided by 6 is 1. Which remainder 3. So if you look at this again, I take my one whole and I bring over the 3 and I bring over the 6 and we are done. So good luck. Enjoy your improper fractions, children.